Alright gentlemen, in this step I'm going to explain to you how to prepare your electrolyte solution for your silver cell. One of the things I would like to point out is the items that you will need and some items that I've included that will make your job easier. Now, we're going to need our 1000 milliliter beaker. We have this in a piece of powder cream because we've worked so hard to get to this point with this silver. If you set this beaker on this hot plate and it breaks, there goes your money, there goes your silver. But if this beaker breaks, it's going to go nowhere but inside this piece of powder cream dish. And yeah, it'll be a headache to clean it out. Just tip it up, spray it with a bottle, put it in another beaker. You may lose a little bit, but trust me, it'll be a lot better than spilling it all over your surface up here and probably ruining your hot plate. On top of this, we have a watch glass. Now the thing to point out about the watch glass is when we're dissolving this silver, there'll be minute bubbles that come off of that will actually get caught up in the air and get on your hands, or they will be sucked off and you will lose part of your money. So anytime that you're not doing something with the beaker, always keep your watch glass over the top of it. And when you take this watch glass off the top, always tilt it over the top and allow the liquid to run back into the beaker, spraying it with your spray bottle on the fan pattern. My hands are full right now, or I would demonstrate that for you here. The second thing we have, we're going to need 8 troy ounces of silver to make our electrolyte with. Now, this is 256 grams. 8 troy ounces is actually like 248, and I think maybe 0.6 grams. I'm not sure about that. But the reason we're going to use a little bit of extra material here is because our silver is not totally pure. This was some of the good silver that I run first that I showed you in the previous video, and it's the cleanest. So if you don't have something like some pure silver coins or bars to make this electrolytic solution from, that's fine. You could use something that's a little bit trashier. It's just going to cut down on the life of your cell is what it's going to do, which means you're not going to be able to run as much material. So we need 200 and few grams over to make 8 troy ounces to make our solution with. Now back here I have my filter flask with my sidearm, and of course my Buckner funnel right there. I have another 1000 milliliter beaker that's just sort of sitting hanging out in the background. I have my nitric acid inside of a hydrogen peroxide bottle, and that's what I use for smaller storage. You've seen my gallon jugs. Well, these are my smaller storage bottles here because it's not going to take a lot of nitric to make this solution that we're going to make. And I want to point out that when we dissolve our silver into our nitric acid to make a silver nitrate solution, it's very important at this step that we don't have any free nitric left in our acid. And the reason being is if you have free nitric and you pour it into the cell, when you add your silver shot, the process don't start immediately. What has to happen is that free nitric has to be used up so it dissolves more of the silver out of your basket and into your cell solution before it can start precipitating silver crystals on the wall of the cell. So we actually want to cut our nitric short. What you always want to make sure of is that you have silver left over in the bottom after you dissolve. That way you make sure all the free nitric acid is used up. Now, if you was to leave a little free nitric in here and put it over in the cell, when you introduced your shot, it would dissolve into the solution and then it would start precipitating. But that's not a bad thing. It just delays how long the startup of the cell is, plus it robs you of having some of your silver that can be purified. Instead of winding up as purified crystals on the wall of the cell, it winds up dissolving into solution, and we later have to precipitate it out to recover the silver we have in the solution. And once your solution or your electrolyte is spent in your cell, I will show you how to recover the silver that's within the cell also, so you can start the whole process over again, just recycling batches of silver. Now, another thing, you want to make sure that all of your labware and glassware is clean at this point. If you have any chlorides that is on, and you could wash these in regular soap and water, but what I use is a Scotch-Brite pad, and I use Comet, and it cleans off any residual chemicals that may be on this glassware. And my filter flask, I'm going to give y'all a trick here. The easiest way to clean a filter flask is you can't get down in there with a rag, you're left poking with something other down in there. Pick up a toilet brush. You can get them at Walmart. I think I paid $2 for this one. And it squeezes down into the neck and down into the bottom and allows you to clean the inside of this flask. We want everything clean at this point. This is our final step in our process before we introduce this into the cell. That's what refining is cleaning something up every step of the way to reach the end result of a purified metal. We have come too far to introduce foreign substances or trash back into this process. Now, the one good thing about the silver cell and the way that I've set it up is it's tolerant. It's tolerant. If you make a mistake in one area slightly, it'll tolerate it. No matter throughout the process. If you got a little extra nitric in your process in the beginning, you wind up with kind of a dirty product, you'll pay for it, but your electrolyte is what'll suffer in the end. But this system, the way I've set it up, is tolerant of certain things. But you've got to follow the instructions that I've laid out for you. Now, what I'm going to do is I'm going to cut away for just a second, and we're going to come back and we're going to start dissolving our silver into our nitrate solution so we can prepare our solution for the cell so we can start processing shot. Okay, gentlemen, now we're ready to create our silver electrolyte solution for our cell. And of course we have our silver down here that we done pre-measured and determined there's about 250 some odd grams in there. We need 8 ounces in our solution, so we're going to take the top off of our beaker right here, and we're going to take our silver. And you don't want to pour this into a beaker because as it hits the bottom it can break a beaker. We're going to go ahead and add our silver. And for 248 grams of pure silver, we want to multiply that. Remember, it takes 1.22 milliliters of nitric acid to dissolve a gram of pure silver. Now, this silver here is pretty pure already, so it has a little copper in it, and always remember that the copper makes the nitric acid consumption go up. So we could just use the pure silver numbers to go ahead and make our electrolyte. So you want to multiply 248 grams times 1.22 milliliters, and that comes out to 302.5 milliliters of nitric acid to dissolve this silver. Now, we also want to add an equal amount of distilled water. So we would have 302.5 milliliters of nitric acid and 302.5 milliliters of water for a total of about 600 milliliters by the time that we're done here. And you want to add your water to this first. So you want to go ahead and add your whole portion of water, whatever that may be based on whatever numbers you're using. But for this particular experiment, we need to add 302 milliliters of water that I already have measured out here. And we're just going to add that straight to the silver. And by adding the water first and then adding the nitric acid is not as strong and the reaction don't kick off quite as quick. The larger of a surface area that you have, the more reactive a metal is going to be to these acids. The shot has a lot of surface area, but it has a lot of density to it too. Whenever you have real fine powders like what we melted to make this shot, if I was to put fine powder in here and then commence to add nitric acid, this would get real reactive real quick, just like it did out in our tub when we first added nitric acid to it. So we know that we need 302.5 milliliters of nitric acid. So what I'm going to do right off the bat, we don't want to overshoot the nitric acid too bad on this. We just want to get close. If you got some pieces left in the bottom, that's even better. So what I'm going to do is I'm going to go ahead and come over here and measure me out 100 milliliters of nitric acid. I'm going to go ahead and add that to my water in the beaker. Notice the reaction is almost instantaneous. If it's a little colder outside, it may take a little longer for the reaction to kick off. Now, were this a pure silver product, you wouldn't be seeing the light green that you're seeing in there. But that's all right. I like to make my cells up with a little copper in them anyway. That way, the crystals are easier to remove from the sides of the cell. So if you've got some copper in your solution, that's fine. Just remember, copper always equals less amount of silver you're going to be able to process. And as you can see, it's giving off a good red nitrogen dioxide gas. And I'm working in a fume hood here, so I don't have to worry about, I don't have to worry about the fumes or anything. I'm actually able to stand here in front of this. But if you're outside, again, put a fan against your back and blow it across you so you don't inhale this stuff. And let me see if I can get down there and get you a shot. And you can see the shot dissolving, and there's just a little bit of a green hint to the color. That's alright. Now, notice I don't have this hot plate on. This is generating its own heat. And you really don't need to apply heat until the reaction itself just calms down, because it's generating enough heat right now. You don't need any more. That's one of the good things about these chemical processes. You don't have to heat them till the very end. Now, had you turned this hot plate on and got that water hot, real hot, and added that nitric acid, you may have had some problems. So always start cold and don't add too much of anything until these solutions have time to warm up, because they'll take off on a runaway reaction and you'll lose your product. I mean, you could recover it, but you still don't want to be backing up. Let me get down here. And this process here usually doesn't take a very, very long time. Now remember, you want to use distilled water. You don't want to create any chlorides in these solutions. We're going to filter this when it's done, and any chlorides will come out of that, will be trapped in our filter paper, but still it's just money that we're misplacing. We don't want to do that. And I like to give everybody a bird's eye view. You learn the most by observing. I've spent hours watching these processes. Notice the thousands and thousands of tiny, minute bubbles that it's putting off. And we're going to cut away from this for just a minute and give this about another 15 minutes to work off or slow down, and then we'll come back and add some more nitric acid. We've only added 100 milliliters of the 302 milliliters that we need. Okay, gentlemen, we're back. The elapsed time has probably been about 5 minutes. And the solution is still going, but it's starting to slow down quite a bit. So we can go ahead and add another 100 milliliters of our nitric acid to this solution. And what you want to do is you want to take this lid off, and be careful how you handle the bottom of this lid. This is silver nitrate. Remember how my hands turn purple? You actually want to take a spray bottle, pick this lid up, and spray the back side of it on a fan pattern so it just trickles down in there. And since I'm holding this camera, I'm just going to set this back here on my other beaker. And you want to take and wash the inside of your beaker down. As this is fizzing, there's minute particles that come off here that get on your hands, and your hands will have purple dots. So wear your gloves. Now, we're going to go ahead and add another 100 milliliters of the 302.5 milliliters that we need. It's best to balance this on the side and let it run down the side of the beaker instead of pouring it directly out in the middle. You will have splashes everywhere. It gives it a guide. And then we'll place our lid back on here. And if you'll notice, the reaction's starting to get vigorous again. So we're going to cut away, still no heat. We're going to cut away for about another 5 minutes and let this calm down again. Now, it may get kind of high. You could see it rising on this marker up to the 600 milliliter mark. See the reaction? Now, it may climb up there pretty good, but if you've used the materials I've told you to use and done this the proper way, this should not boil out of this beaker. If it starts to boil out the beaker, just get away from it and let it do what it's got to do. You do not want these chemicals all over you. We're going to cut away for a minute and probably give this about 5 minutes to calm down. We've put about 204 or 5 milliliters of the 300 in there that we need for dissolving our silver shot. So we only like another 100 milliliters of nitric acid. So we're going to give this time to calm down a little bit and cut away, and I'll be back with you gentlemen in a moment. Okay, gentlemen, we're back again. It's probably been a good another 8 to 10 minutes, and our reaction has again calmed down. It hasn't totally quit, but that's fine. It's calmed down a little bit. And if you'll notice, we're at about the 500 milliliter mark. Now remember, we're adding 300 milliliters of nitric, 300 milliliters of water, so in the end we should be around the 600 milliliter mark, which is perfect because the capacity of the beaker that you're running this in, you should never fill your beaker over 2/3 its capacity. That's a rule of thumb. You leave the other third for expansion. If you was to fill this beaker any higher and you had an overflow or you had a quick thermal reaction, it would overflow. So we're right within the parameters of where we want to be. We need to add another 100 milliliters of nitric, and that should get us pretty close to where we want to be done at. And as you could see some trash floating around in there, black. Now that could either be residual gold or that could be flux that came out the dish, or some oxides of some type that may not be dissolving in the nitric. Those will be removed when we filter them through our Buckner funnel in a moment. So we're going to go ahead and add our other 100 milliliters of nitric to make it 300 milliliters of nitric for our solution, and that should be all that we should need to add. So again, remove your lid, tipping it up, squirt the back side so that all the solution runs inside of your beaker. We'll rinse the inside of this down. You don't necessarily have to do this, but I like to keep it rinsed down. And we're going to add our last 100 milliliters of nitric, pouring it down the side again. And watch the reaction take off. And let's put our lid back on here. Now, what we can go ahead and do is, since this reaction is pretty calm at this point, we can go ahead and start adding a little heat. You just want gradual heat. You don't want medium heat. You want low heat. And then you can gradually turn it up to make the reaction go faster and to drive it forward. Now, we're probably about 12 to 15 minutes into this process. We should be finished up in about a 30-minute time span from start to finish for dissolving. Now I'm going to go ahead and cut away here again, and we're going to give this about 10 minutes and come back and check on it again. Again, notice the nitrogen dioxide gas that's still being given off as the reaction goes. Okay, we're about 10 minutes after our last addition of nitric acid, and there's still some material left in the bottom of the beaker. And if you'll notice, as the reaction started to slow down, I've turned this up to keep the reaction moving forward. So we're about totally 20 minutes into the process, and we're probably about 95% done. So I've turned this up. We're going to cut away, give it about another 10 minutes for a total of about 30 minutes dissolving time, and we should be about ready to move on to our filtration stage. So I'll see you gentlemen in 10 minutes. Alright gentlemen, we're back again. It's been about 10 or 15 minutes since our last check-in. We're probably 35 minutes into the total process, and I've increased my heat some. And if you'll notice, there's hardly any red gas being put off, which tells us we're almost at the end of our cycle. Now, I want to show you here. You could take a glass stirring rod and you could reach down in there and you can feel around to see if you have any materials left in there. And there's almost nothing left. When you pull your rod out, make sure you rinse it off. Let's look through the bottom here, and if you don't have experience, I wouldn't recommend you picking these hot beakers up. I've done this for quite a while. I feel comfortable with it, but I wouldn't recommend it for you. And if we'll look on the bottom there, we can see we have just a little bit of silver still left in our solution. So we're going to leave it on the hot plate about another 10 minutes and try to digest as much of that silver as we can so that we don't have any free nitric left in our solution. So we're going to cut away, give this about another 10 minutes, and that means we're going to be about 40 minutes into this process. Once it's dissolved, we're going to cut the temperature off and allow it to cool for about an hour before we try to filter it. I'll see you gentlemen in 10 more minutes. Alright gentlemen, last check-in. It's been about 40 minutes now. Our hot plate's turned up. Our dissolving is all but done, and the way that we know this is we're not putting off any more of the red nitrogen dioxide gas. So let's pick our beaker up, take our top off, and I'm going to look in the bottom. Again, I don't recommend this for you. And there's still just a few pieces of silver floating around in there. But there's no more free nitric acid. So instead of adding more nitric acid just to dissolve that little bit right there, we'll say we got close enough and we'll turn this off, and what will probably happen is that little bit will finish dissolving over the next hour or so as this solution cools. If not, it will be trapped in your filter paper in your Buckner funnel and you will be able to recover it. So we're going to turn this off and give this about an hour to cool down so we can handle it. Then we're going to come back, filter our solution, our electrolyte solution, so we make sure it's good and clean for the introduction into the silver cell. So I'll see you gentlemen in about an hour. Alright gentlemen, our hot plate is off. Our solution has cooled for about 2 hours now, and everything has started to settle down. And you can see how clear the solution is in here, and the powders that are on bottom. Now that may be flux that was left over whenever we originally shotted our silver, or that could be some gold powder in the bottom there from where I had done some incorting before. Or it could be several things that are in the bottom of that, some leftover silver even. But what we want to do at this point is we want to take this solution and we want to filter it through our Buckner funnel up here. And what I have here is a 1,000 milliliter vacuum flask with a 9 centimeter Buckner funnel up on top. And it just takes regular filter papers. You can buy these, they're cheap, $3 or $4 a pack. You get 100 of them in there. If you don't do a lot, they'll last forever. And you want to lay 2 filter papers in the bottom of that funnel. If you just put one in there, you're going to suck a hole through it. So put 2 filter papers in the bottom of your Buckner funnel. You want to take a spray bottle and you want to wet them filters once they're in the funnel so they can form to the shape and the bottom of the funnel before you apply vacuum to your flask, or your filter papers won't lay straight on the bottom and you'll wind up sucking this tiny minute trash through and into your electrolyte solution. Now what I'm going to do here is I'm going to go ahead and cut away for a second, and we're going to set up our funnel apparatus and we're going to get ready to funnel our solution. Okay gentlemen, we're back, and as you can see we have our filter apparatus set up, our Buckner funnel and our flask, and we're ready to filter through our solution to clean it up. So what we're going to do is we're just going to take our beaker, and with vacuum already applied to it, we're just going to pour it directly in the top of the beaker. Now you want to try to leave everything that's in the bottom of this beaker in the bottom of it. Just don't swirl it around and then try to pour everything into this filter. And as you can see, it's a good clean solution. It's filtering through pretty good. It's got a little hint of green in it. That was from our copper that we used it from our cemented silver to make our electrolyte solution. And again, even though in the bottom of that beaker it looked like a lot of trash in the solution, what the solution does is it magnifies anything that's in the beaker, just like a magnifying glass does. Now you want to take your squirt bottle and you want to rinse all of that out into the top of your filter. You want a clean beaker. because what we're going to do next is we're going to pour this solution back into this beaker and filter it through this funnel for a second pass. You always want to do this a second time, because even as good as them filter papers are, there are some minute particles that get through this and will wind up in your solution in your cell. So this is what we refer to as packing a filter. You run the solution through it the first time to stop it up real good, and the second time you pour it through there, it catches the real tiny fine minute particles. Now I'm going to cut away just a second and rinse this beaker off, and I shall be right back. Okay, now that I've rinsed my beaker out and cleaned it of any foreign particles, we're ready to pour this solution back over into our beaker and run it through the top of our Buckner funnel a second time. So let's see if we can get a shot. That solution looks good and clear, and you probably won't see this on camera, but the second filtration really makes a difference that you can see with your eye. So what I'm going to do is I'm going to disconnect my vacuum, pick your funnel up. I always have a place to set my funnel, and mine's inside of another beaker, so if anything drips out, I can add it back later on. Then we're going to take this and we're going to pour it into our 1,000 milliliter beaker. Now, whenever you pour this back into this beaker, let's go ahead and do this. All that dripping off the end right there is silver nitrate. That's money also. So you're going to want to take that spray bottle, and if I wasn't holding this camera, I'd take the spray bottle in the other hand, tilt it backwards, and spray around the rim, allowing it to drop in. Then you're going to take a spray bottle and squirt the insides and rinse this into here 2 or 3 times, because there may be minute particles that made it through the filter that's still in the flask. There's no use of filtering it a second time if we've left trash in here. So we need to take our spray bottle, point it up in there, rinse it out real good, and then pour all of them contents into our beaker, set our flask up a second time, put our filter back on top of it, and then run this solution through it again, and it'll be ready for introduction into our silver cell. So I'm going to cut away again. I need to rinse this flask into here to get the trash out of it, and then I'll pick up where I left off. Okay, we have our Buckner funnel set back up after we've cleaned and rinsed our flask out real good into our beaker. And just to give you an idea, this is pretty clean the way it is now. I hope this video shows some definition. But remember, a pure nitrate solution should be crystal clear like water. This has a little bit of copper in it, and that's why it has a little bit of tint to it. But rest assured, our silver is in there. So what we want to do is we want to pass this through the funnel a second time. And you want to watch those drips on the end of the beaker right there. You can see that one hanging on. You just want to kind of rub it off. What will happen is when you set your beaker back up, that drip will run right back down the face of that beaker, and you'll either get it on your hands or you'll lose your money. Now, silver is not as expensive as gold, but if I had a drip of gold come off the end of that beaker, it may not sound like much, but that's $1 or $2 traveling down the outside of that beaker. You need to catch it. Take you a little piece of paper towel, rip it off, and just wipe the front of the beaker, and then take that and add it with your filter papers, because that has silver on it now also, so there's money in that. So add it to your filter papers. And our solution has been and I can definitely tell a difference to the color of the second solution versus the first as far as clarity. It's like it clears up. Alright, our funnel is about dry up here. We want to add some more of our solution. And we'll give that a minute to filter down also. And your buttoner funnel shouldn't be broken on the end like mine is. I actually chipped the end of mine, but a regular buttoner funnel doesn't look like that. And we just about sucked all this down. We could go ahead and add the rest of what's in our beaker. And remember, while you're tilting this beaker up, you want to take a spray bottle and you want to rinse the inside of your beaker out into this buttoner funnel right here. You want to get the last bit of that solution out. Because what we're going to do is we're going to take this flask and we're going to transfer this directly to our silver cell now for use. So make sure you get everything out of this beaker and get it rinsed down with a spray bottle. Okay, now that our solution has siphoned through, we want to take our spray bottle and we want to, okay, now that our solution has been vacuumed through our filter paper, we want to take our spray bottle and we want to set it on a fan pattern, gentle mist. Then we want to come in and wash down the insides of our buttoner funnel and spray across the top of that material that's in there and give that a second to draw down. And we're just trying to wash any residual nitrate out of the material, the filter paper, and anywhere inside of this neck that silver may be collected at. We don't want to leave silver in our funnel. So just come back and add some more water. Give it a second, and by drawing down excuse me, it will leach the last little bit of silver nitrate out of your paper. If you just keep throwing water and don't allow it to suck that down like a sponge, it won't get all of it out. So just take your spray bottle, wash your material in the inside of your funnels 2 or 3 times. You can look down here at the bottom. You'll start seeing clear drops come out whenever you get to your pure water. Distilled water again. I've stressed that several times. Alright, we're going to wash that material one more time. Let that sit for a second. Until we really don't see any more drops coming out the bottom of our funnel. they're starting to slow down. Alrighty. Now once it finishes dripping, what you want to do is you want to take your vacuum off of your flask, remove your funnel, and you want to spray the insides of this flask to kind of make any of the nitrate solution. As it drips down in here, it drips all up on the side of the flask. You just want to wash the flask around so it washes back down in the solution. And there we have our first batch of electrolyte ready to start our silver cell up. So I'll go over here and take this with me, and I'll show you how we get our silver cell set up and ready to run some of the shot that we have. Alright gentlemen, we're back again, and as in the previous video I showed you how to dissolve your cemented silver into a nitrate solution to make your electrolyte. Well, what I have here is a follow-up, and this is some of the silver crystals that we've run through our cell, and I've just harvested these and I'm fixing to make another electrolyte solution to restart my cell for the next 50 ounce process. But I just wanted to take a minute to let you see the difference in the solution colors as to when you run a pure silver crystal and whenever you run a trashier material like cemented silver that may have some copper in it. Now in our original video we needed 8 troy ounces to make up our electrolyte solution, and that comes out to 8 troy ounces times 31.1 grams per troy ounce equals 248 grams of silver. And what we have here is 248 grams of our silver from our silver cell. And if you'll notice on the back sides of some of these where it adhered to the bowl, you could actually see a shiny reflective silver metal. So we need 248 grams of our silver crystals to make another solution. Now we also learned that it takes 1.2 milliliters to dissolve 1 gram of pure silver. So we need to multiply 248 times 1.2 milliliters, and we come out needing 298 milliliters of nitric. We also learned that we need the equal amount of distilled water. So we'll round up and call that 300 milliliters of distilled water and 298 milliliters of nitric acid. So, and we always want to have our watch glass handy. So what we always do first is we add our water to our beaker. That way our nitric acid is not as reactive. And here is 200 milliliters of water. And we need another 100 milliliters of water. Our other 100 milliliters of water. Now we've added all of our water, we can go ahead and add our shot. And this is our, again, our pure silver crystals from our silver cell. And remember, you don't want to drop them in the bottom of a beaker. They're heavy. Sometimes you can actually crack a beaker. And we'll get all that in there. Now, remember, we also need 298 milliliters of nitric acid. But we never want to add all of our nitric acid at one time. If we add all of our nitric acid at one time, we're liable to have a boil over. These crystals have a lot of surface area like the powder, which means they are very reactive to these chemicals. So, if we need 298, let's say 300, but we're not putting that in there, we're going to get as close as we can. We're going to go ahead and add 1/3 of that. So we're going to add about 100 milliliters of nitric. And we're going to come over here, and remember, we have no heat on our hot plate. I'm going to add probably about 50 and give that a second to start. And let's see what kind of reaction we get and how vigorous that reaction is. And if you'll note, we start to have the red nitrogen dioxide form over the top of our solution. That lets us know that there's a reaction going on down here. Okay, I'm going to go ahead and add the other 50. For a total of 100 milliliters of the 298 that we need to make this solution. And we'll give that just a second to react. You can feel the side of your beaker. This one feels lukewarm, so that tells me that I don't have a very vigorous reaction yet. So we'll give that just a couple of minutes, and we'll cut away and we'll let this work for a minute, and we'll see how it goes at about 5 minutes, and we'll come back to this. Okay, gentlemen, it's only been about 3 or 4 minutes, but we're not getting a very vigorous reaction from our first 100 milliliters. So I'm going to go ahead and apply another 100 milliliters, which ought to make it a little ornery. Let's see how it reacts now. And if you'll notice, our solution is still clear. And the reaction proceeds. We can see the tiny minute bubbles that we know were formed during a chemical reaction. We can also see the red gas that's given off on top. That's an indicator that a chemical reaction is occurring. And it's getting a little more vigorous. That's why we always leave a third of the capacity in our beaker above our solution, so our solutions have rooms to expand. This one is expanded 150 milliliters already. Okay, we're going to give this 3 or 4 minutes to go on and continue to react. We still like adding another 98 milliliters of nitric acid to complete our process. Our beaker is starting to heat up on the sides, and what I'll do once the reaction calms down after the second stage, a lot of time, as you can see, it's starting to calm down. The volume of the solution is dropping. A lot of times I'll turn my hot plate just on a little warm to push the reaction. You don't want to add too much heat yet. We're going to generate some more heat in the next step when we add the other 98 milliliters of nitric acid. And the hotter the solution is, the more exothermic it's going to be. So we're going to go ahead and cut away now. And I'm going to let this settle down for another couple of minutes, and then we're going to come back and we're going to add our other 98 milliliters of nitric acid to go ahead and finish making up our electrolyte solution. Okay, gentlemen, it's probably been about 5 to 7 minutes now, and I have my hot plate on a low temperature setting, and as you can see, the solution is calmed down again. So I'm going to add my final 98 milliliters of nitric acid to this solution. And as you can see, it will take off again. And if you look down here close to the bottom, you can see our silver laying in it and the way that the acid attacks. As you can can see, our level has risen again right above the 600 mark. We've still got plenty of room for expansion, so we're doing good. And it's going to start to calm down again here in just a minute. So I'm going to go ahead and increase my heat to about a medium setting at this point, because I'm wanting to drive this reaction forward. I'm wanting to use all the nitric that's in here. But like in the last clip of the video that I done on dissolving cement in silver, if there's a little nitric acid, it's alright. Some of your silver will just dissolve out your basket a little quicker. This process is very tolerable. As long as you get within the required limits, you shouldn't have any problems. And we're holding right at 600 milliliters. That tells us that our solution is steadying out, and in a minute it will start to drop. As we add more heat, we're pushing this process forward a little faster. Heat equals reaction. Surface area equals reaction. There's all sorts of different ways that you can control these chemical processes whenever you're doing them. So what we're going to do is we're going to cut away, and we're going to give this about 10 minutes on a medium setting, because as the last of the nitric gets expended, it takes longer for that last few nitrate ions to find the silver that's in there. And by increasing heat, we make those ions angry. They bounce around in there quicker and faster. And the quicker they bounce around, the quicker they're going to find their target, our silver. So we're going to cut away and give this about 10 minutes, and we're going to come back and take a look. And when this finishes dissolving, we're going to run it through our Buckner funnel again to clean this solution up before we introduce it into the cell, and we'll get an idea of the clarity of this solution versus one of cemented silver. Alright gentlemen, here we are about 30-35 minutes in the dissolving process. It's been 20 minutes since I seen you last. I had my hot plate on about a medium setting for the last 15 or 20 minutes until all my silver dissolved. I've now turned my hot plate off, and if you'll notice, we have a totally clear solution. And once we filter this, you will get an idea of the clarity of this solution. So what I'm going to do is cut away, give this about an hour to cool down so we can handle the beaker safely, and then we're going to filter it through a Buckner funnel again, and I'm going to show you the clarity of a clear silver nitrate solution. Okay gentlemen, we're back. Now that my solution has cooled off a little bit, I've set up my Buckner funnel setup with 2 filter papers in it. And we have our clear silver nitrate solution. And what we're going to do is we're just going to run this through our Buckner funnel twice, always twice, to get an idea of the clarity. Now, if you'll notice, this looks super clear. We're going to go ahead and filter this the first time through our Buckner funnel. And as you can see, it passes through our Buckner funnel rather quick. And you're going to want to take a spray ball and wash any residuals out of that beaker into this funnel. Now I'm going to cut away for a minute. I'm going to recover my silver nitrate solution, pour it back into my funnel here after I've rinsed it out, and we're going to run it again just to make double sure that our solution is good and clean. So I'll be back with you gentlemen in just a moment. Okay gentlemen, here is our silver nitrate solution after our first filtration, and you can see the clarity of that solution. So we're going to go ahead and filter a second time just to make sure that we've got everything nice and clean for introduction into our silver cell. And we're just going to take this and pour it through the top a second time. And you can see how easy and how clean and how quick that this filters. And then again, you want to take a spray bottle and wash all this into your filter. You want to take a spray bottle and rinse your filter well, so that you get all of the residual silver nitrate out of the filter that's possible. And then we'll take what's in the flask down here, and we'll add that to our silver cell as our electrolytic solution. We'll just put our spray bottle on fan here, and we'll just wash the sides of our funnel down and wash anything out of our filter paper that may be in there. Give it time to draw down good. Repeat. Then you're going to want to remove this once it sucks the filter dry. Introduce this into your silver cell. Take the filter paper that's in here and add it with all your other filter papers for processing later for the recovery of the silver that's trapped inside the filter paper. And let's take a look at this solution now, and I believe you can see the clarity of this solution. Crystal clear almost. And that tells us that we've done a good job with our purification of our silver crystals in our cell. Had there been any copper or any other contaminants, this solution would not have the clear, distinct clarity and color that it does. Now, if you wanted to, you could evaporate that solution down and make silver nitrate crystals out of it. You can start a silver cell with silver nitrate crystals, dried crystals. All you need to do is add water and bring your solution up to what the calculations are that you need, and silver nitrate crystals and water is all you need. No nitric acid. So, I'm going to go ahead and cut away now and end this little demonstration, and we'll see you gentlemen in just a little while. Alright gentlemen, we've got all of our items set up to get our silver cell ready to start running. Boy, it's been a long path up till here. But what we have here is I have a power transformer that allows me to adjust my current and my voltage to my cell. Now an important note here, don't use another type of power supply. Don't try to use battery charger, it won't work. About the highest you want this voltage to approach is about 4 to 4.1, 4.2 volts. Once you get over that voltage, if there's any other elements dissolved into our electrolyte solution from contaminants, they will start to co-precipitate with the silver crystals on the bowl surface. So what we're going to do is we're not going to try to set our amperage, because we could set our amperage up to 5 amps. This one's good up until 5 amps. You can get them all the way up to 10 amps off of eBay. I believe I paid $65, $70 for this. But you can crank the amps all the way up and your voltage will rise till 7, 8, 9, 10, 12 volts. You can't do that. All we're going to adjust is our voltage, and we'll allow our amperage to float. So, and on top of that, we have our cell basket, which in the previous video I demonstrated how to set up your filter basket for your cell. we have our stainless steel bowl, which I've cleaned good. You want to make sure that the inside surface is clean, don't have any dust or contaminants from sitting around. Over here we have our top cover for our silver cell. We have our solution that we made for our electrolyte. And over here I have some silver bars that I'm also going to include in this video and put in the cell basket, so you can see you can run silver bars the same as you can shot. The reason we use shot is because after you melt the cemented silver, you don't want to go to the trouble of pouring it all into them bars just to dissolve the bars again. So you can just pour it directly in water as shot. And the shot gives more surface area than the bars does. So this cell is made to digest silver faster in a shot form than it is in a bar form. Now what we have down here we'll call our candlestick. And this is what we're going to use is an anode bar to make connection to our bars in the basket and our shot in the basket. We're going to have to make electrical connection, and the best way is to pour this candlestick holder. This may change, the design may change, so if the type of mold that you get in your kit is not exactly as the same as this, don't panic, it serves the same purpose. But this is what I've been making my rods out of and what I continue to make my rods out of. And the anode is this bar. The cathode is the whole surface of the stainless steel bowl itself. So we're going to attach our positive lead to our anode, and we're going to attach our negative lead just to the outside of this bowl lip, making the whole bowl the cathode in essence. So what we're going to do now is we're going to go ahead and we're going to take our lid and we're going to position it about dead center of our bowl there. And then we're going to take our filter basket and place it in the hole in the middle. From there, you're going to take your electrolyte solution and you're going to go ahead, even though it's clean, you're going to pour it through this basket, and it'll pre-wet this basket material is what it'll do. Plus, if anything happened to get into it, it'll get caught again in this material right here. So we're just going to want to add this to it, and again, when you're finished, chip it up, take a spray bottle, rinse out the inside into your basket right here. Now we want to kind of try to hit the middle of this basket the best that we can. And we just want to pour the basket up with solution and give it a second to drain down. And you can see it's draining to the bottom. And we'll add a little more. And we're still continuing to allow it to drain through the filter basket. And notice how once we start running silver through this, the color of the solution will go from green to more likely a real pretty blue. Sometimes it'll stay green, but usually it'll go blue, and that'll be some nickel and some other contaminants in our silver shot and bars that will be coming out and changing the color of the solution. Now that I finished this, like I said, tip it up, take your spray bottle, spray the inside of your beaker, and allow it to run down into your filter basket. I'm going to cut away for just a moment, and I'm going to go ahead and do that, and then we'll come back and I'll show you how to start your cell up. Okay, gentlemen, I'm back. We've got our electrolyte solution in our bowl here, and as you can see, it just filtered right through the basket. Okay, remember, always use a double layer of cloth in this basket. Now, your 1,000 milliliter beaker comes in handy whenever you want to pick this up out of the solution and set it somewhere to allow it to drip while you may be working in your cell. But I took this off just to give you an idea of the color that we have in our cell and the clarity of our solution. See how clear that is? Crystal. You can see the scratches on the bottom of the pan. Alright, we're going to place our lid back squarely in the middle. Place our basket back inside of that. And now what I'm going to show you how to do is to load your basket with silver shot or bars. And one important note I'd like to make here is once we introduce our silver into our basket, we don't want to be prodding at this basket material. Don't come out here with a stir stick or a fork or anything that's going to puncture this and go to playing with this. There's no reason to doing that. You just keep throwing silver in this basket. As it weights down on itself, it will make contact and it will dissolve. Only time that it won't dissolve maybe is when you get to the very end of the process and you may have some little bitty pieces left in the bottom of the basket. But the bar itself that we're going to use is our anode bar is even going to dissolve into the solution over time. So what I'm going to do first is I'm going to go ahead and take a couple of these bars and lay them in the bottom. The reason being is if they're on the bottom, this shot will surround it. And as this shot surrounds it, it will make contact with it and all of it will dissolve into the solution. So I'm taking these bars that I have here and I'm going to go ahead and put them in the very, very bottom. Again, being careful. You don't want to poke at this. You don't want to do anything to harm this. And then we're going to take some of our silver shot and we're just going to dump it in the basket right there. Just dump it in there. That's all you want to do. And we're going to kind of coat the bottom of that basket with silver shot over the top of them bars. And then you can make it 2 to 3 inches deep. And then you want to come in and you want to stick your anode bar in here. And you just want to fill in around it with shot. That way you've got plenty of surface area to make contact. But you don't want to drop this stuff like I am. Let me pick those few pieces up. Alright. And then make sure your bar is down in there a little bit, and it don't have to, your bar don't have to be submerged and surrounded by it. I mean, your bar could still be up here and your silver can even be out of this basket up to the top because it's just going to all dissolve down to the very bottom anyway. So you just keep feeding that silver in that basket, piling it up. Take your anode bar, work it down in there to where you get contact. Then you want to take your positive lead, the red wire, clip it to your anode bar. You want to take your negative lead, which is the black wire, and just clip it on the outside lip of this bowl. Just clip it right on there, anywhere as long as it's making contact with it. Alright, now what we need to do is we need to make up this electrolyte solution because as you can tell it's not reaching any of our silver in the basket. So what we're going to do is we're going to add enough water to bring this up almost to the bottom level of the inside of the lip on the stainless steel bowl. You want to leave about a ½ inch from the top not filled with water, but we're going to fill this up with water until we reach the very top of the basket or close to it. Okay, now what we want to do is add distilled water distilled to make up this difference that we have in solution. And again, just pour it in there on top of the silver shot like we did earlier, and just let it drain through. And as you can see, it runs through pretty good. And we're just going to keep adding water until we get up close to the 1/2 inch mark on the bowl. And it'll probably take you about 2 liters of distilled water to reach that point. Now, once we get our bowl up here within a 1/2 inch of our top, we're going to get all this hooked up, and I'm going to show you about the voltages and the amperages that we need to be running. So I'm going to cut away now, get some more distilled water, finish filling this up, and I'll be right back with you. Alright gentlemen, we're back after we've got our electrolyte solution in our silver cell and we're ready to go. But I wanted to show you something. I added some water in here earlier from a beaker, and that beaker had nothing but plain water in it, and as you can see, my solution now has a cloudiness to it, and those was just a little bit of minute silver chloride that precipitated. But once you start running your cell, after a couple of hours, that'll usually clear up and you won't see it. None of that is usually transferred over to your final product, and if there is just a few chlorides in there, by the time you finish your final washes and your melting, those will be gone. Now, we've got our positive lead hooked to our candlestick anode, and our bowl serves as our cathode. Now, what we need to do here is we need to figure out how much voltage to apply. And what I have here is a maximum 5 amp DC power supply. And this has an automatic cutout switch, so if something shorts out, you're not going to have a problem in your cell because this thing will cut it out. Do not use a battery charger with this cell. Do not let anybody tell you to use a battery charger with a silver cell. It puts out too many volts. It's not the amps we're concerned with, it's the volts. Pure silver really precipitates out in the cell at around 2.1 to 2.4 volts. Now that can go upwards of up to about 3.84 volts. But when you start pushing the upward edge of that envelope, you start precipitating other metals in with your silver crystals. So you're co-precipitating metals and you're defeating the purpose of what you're trying to do. So at no time do we ever want to see the voltage as a maximum get over about 4 volts. Anything under that is ideal. The closer to 2.1, if you've got time to let your crystals grow, that's fine. But what we're going to do here is I have the current turned all the way down. I have the voltage turned all the way down. Now what I'm going to do is I'm going to turn my power supply on now, and I'm going to turn my amperage current all the way up. That's the maximum. The way we're going to set this cell is to operate by the voltage, and our amperage will float. So what we want to do is we want to start to increase our voltage until we get right up around the 3.5 mark, 3.4, somewhere in there. And then you can fine tune it up till you get to about the 4 volt mark. And as the electrolyte in the cell starts to balance out, these numbers won't fluctuate as much up here on the screen. It'll take an hour or two of running for the solution to balance out and for the cloudiness to disappear. And you'll probably start seeing small silver crystals within the first 2 hours. But once the solution clears up, you'll start to see them all over the bowl. And what happens is we're not making long, thick crystals. If you had a smaller cathode area, you can make bigger crystals. But that's not our point. Our point is to purify the silver in the quickest manner possible. And with this cell having this much cathode area, it's spread out more, which means you can run more silver through this cell using this stainless bowl design than you can with a piece of graphite. And you don't have to empty the cell near as much. On a piece of graphite, it builds up on the surface and you have to periodically knock it off. With the stainless bowl, you can actually build many ounces before it ever starts to reach the bottom of your filter basket. Now in a regular silver cell, if you have crystals grow from the graphite or the stainless and the basket is not a far enough distance away, they will grow together and actually short out. So again, we're just going to adjust our voltage up to about the 384 range, anywhere in there, and we're not going to worry about our amperage. It's turned all the way up. We're going to let the amperage float, and the voltage is what we want to pay special attention to. So now I'm going to cut away for just a few minutes, and we're going to give this thing about an hour to run, and I'm going to come back and check on the solution and see if we can see any crystals starting to form and to see how clear that the solution is. So I will see you gentlemen in just a moment. Okay gentlemen, we're back. It's been roughly about 4 hours now, and we're going to check in on our cell. And I wanted to mention earlier, you can pick up these transformers on eBay, the 5 amp or the 10 amp. I think the 5 amp's going for about $70 right now. The 10 amp maybe $100. But the difference in amperage, if you throw more amps to it, you'll be able to produce more silver quicker in this cell. The design of the stainless steel bowl is unique in the fact that it gives up heat very easily, so it keeps your cell running cold whenever you have a lot of amperage through it. As you know, when you use electricity, you create heat. Well, the stainless surface helps radiate that heat. And as you can see, we're hanging at about 4 volts still, but our amperage has climbed. We're up to about 1.76 amps. And like I said, the longer this cell runs, the higher the amperage will climb up till its limit of 5 amps. Okay, now if you'll notice, I don't know if you could tell, but we have some silver crystals growing on the surface of the bowl. And they kind of look like barnacles down in there is what they look like. If I could do this without the light. Let me grab a flashlight. And let's see if you can see anything sparkly down in there. I think you can see the light reflecting off maybe. Yeah, maybe that'll help you. But it's been about 4 hours now, and it's really not started precipitating real good. What it's doing is it's building a foundation, and then all of a sudden you'll look in here tomorrow and there'll be crystals lined around this bowl. It will look like diamonds. And if you'll notice, the clarity is starting to get a little better. So our chlorides are starting to be absorbed into the cell. Now, let's see if I can slide this back a little bit. Alrighty. And let's try to have a look down in here. See if we can see anything. I think you can make out some of the crystals there. and we're going to take a break for a little while, and I'm going to go to sleep. And we're probably going to check back on the cell after it's run about 12 hours, I guess. So I'm going to go ahead and cut away, and I'll see you gentlemen in about 12 hours. Alright gentlemen, I'm back, and good morning. I actually had something to do this morning, so this clip will be about 15 to 16 hours into the process. And over here you will notice we're still holding a steady 4 volts, and our amps have climbed to 4.1 volts. Now, after I hit about 24 hours, this power supply is going to be maxed out at 5 amps. I have a 10 amp. I use the 5 amp for the demonstration. You can buy the 10 amp, and the reason I recommend the 10 amp is in a silver cell, it's not the voltage that's important as much as the amperage for production. The more amps you put into the cell, the quicker you will be able to produce silver. So a 10 amp power supply, once this is running wide open, will run twice as much silver in this cell as this 5 amp will. Now remember, I told you I've kind of designed and engineered this little system. The more amperages you run through this cell, the hotter the cell is going to heat up. But because it's made of stainless, it's able to easily radiate that. So we're going to take a look in our cell now and see how we're coming along. And as you can see, it's cleared up quite a bit, and the silver hasn't went down much, but that's because that I've piled probably 40 ounces in that basket, I guess. And like I said, production is tied directly to amperage, so we have just started getting good real high amperage through our cell. Now, like I said, this will peak out at 5 because that's what this is rated for. But if I had a bigger transformer, this would travel all the way up to 10 within probably the first 24 to 26 hour period. And once this gets warmed up and starts throwing the amperages out, it will start devouring silver at a pretty good rate. It's sort of a downhill slope, I guess. It takes the first 24 hours to get the system balanced out, and then it starts running continuously. And the silver cell is really not a single-use project. It's really for setting up and running continuous processes through this system. That way you don't ever have to stop once it's cranked up, it's warmed up. It's like a piece of machinery. At a plant, I've worked at plants in the past where once we crank up a piece of machinery, you don't ever shut it back down, except, you know, when you need maintenance or something, because it takes too long to bring that piece of machinery back up to a working stance. So the silver cell this way operates the same way. A lot of people say, well, I put 20 ounces in the basket and I didn't get 20 ounces of silver. Well, you're not supposed to. There again, it's meant as a batch process. In other words, if you continually process silver through this, you won't lose any silver. You might misplace it. It might be caught up in your filters, it may be in your solution, but as long as you never throw anything away, you can't misplace your values. You can't lose your silver. So as we go through the processes, we're constantly building up our filters and our used solutions, and we're recycling them. So in a batch process, we never actually lose any metals. But if you put 20 ounces in here and run it, you're going to get something like 17 or 18 and a half ounces back, and you're going to say, oh, where's my silver? Well, it's either tied up in the solution, caught up in your filter baskets, or you've lost it somewhere in the bottom of one of your 5-gallon bucket waste disposal disposal buckets. So the silver cell, the way this is designed, is meant as a full-time operation, more or less. Now if you're not using it, you can take the cup out, you can put a top across it, and you can leave this electrolyte in here pretty much indefinitely until the next time that you come back and you get ready to do another process. You can do it that way. There's several different ways you could operate this cell. You know, according to what you're trying to achieve, it's going to dictate what your best process is. And unfortunately for me, I can't tell you that on this video. All I can do is demonstrate it. And let's look at our cell now. And if you'll notice, we have got crystals. And I'm just going to unclip this back lead here. And I'm going to push this back. You always want to make sure that cup is in the center of the cell. If I was to run this where it's pushed back at right now, what would happen is that I would have an unequal balance in my solution, and I would actually start to grow more silver on the side of the bowl closest to where this cup is at. So if you move this cup around, it will cause silver to precipitate thicker or shallower in different areas. And as you can see, we have crystals growing all over the surface of the bowl. And once these crystals build up a good profile around the surface of the bowl, it will really start to charge and take off then. Remember, we don't want to be in here knocking these crystals off. These crystals are going to help our other crystals build. That's what they build upon. So you only want to empty this cell one time after you run 50 ounces. It is capable of building 50 ounces in this cell before you empty it. And then it will come out like sheets of silver, but easily broken up. Let me see if I can zoom in here and give you an idea of some of the crystals. I don't know how much definition I'm really getting out of these shots. This LCD doesn't do a good job of displaying as good as a video monitor, but I'll try to get you a few. They start to actually look like millions and millions of shiny diamonds. And the bottom of the bowl. They look sort of like little sea barnacles at this point. Alrighty, let's zoom back out. And notice that our solution is pretty clear of our silver chlorides that we introduced earlier. I don't know if you could see how good it is on this camera shot or not, but it's fairly clear besides the green tint to the solution. And the green tint to the solution, again, is going to be copper. And the more of this silver that we run through here, the darker that copper content of that cell is going to get. But, alright, let me set my cell back up here. We're going to go ahead and cut away now. And I'm going to come back at probably the 24-hour mark. And we'll see how our cell is doing then. Let's make sure that we got everything set up. And I'll see you gentlemen in 24 hours.